Thank you for the introduction. On behalf of Geno, we would like to thank you for the invitation to talk about such an important and interesting topic. And during this presentation, we will briefly talk about what we have achieved in our selection program so far in order to reduce the climate impact from the dairy sector. So we will talk about the breeding for climate-friendly cow, past success and the future perspectives of the breeding program of Norwegian Red dairy cattle. So the presenters today, I am Karoline Bakke Wethal and work as a researcher in Geno. I will firstly explain what we have achieved in our breeding strategy so far with the indirect effect on the climate. And then my colleague Kirsti will introduce you to Genos' future ambitions and goals for selecting a more climate-friendly and sustainable dairy cow. Different potential ways to reduce the greenhouse gas emissions from ruminants have gained increased international focus lately, and there is a large quantity of studies investigating different ways to reduce the production of enteric methane from both dairy and beef cattle breeds. The greenhouse gas emissions in million ton CO2 equivalents are shown in the graph, and you can see that the different sectors in Norway have a different variation in their emissions. It is important to remember that even though emissions from the ruminants have a climate impact, it is still the emissions from the industrial sector, oil and gas sector, as well as the transport and the car traffic sector still have the largest emission rates, which can be seen in the graph as blue and black and green. And in 2016, they emitted around 45 million ton CO2 equivalents, while around 9 to 10% of the total emissions came from the agricultural sector. Out of the total greenhouse gas emissions from the Norwegian agricultural sector, the emissions from ruminants is about 50%. And looking at the greenhouse gas emissions from dairy cattle, you can see that approximately 50% of the relative greenhouse gas emissions is coming from the enteric methane production. And this is a potential to achieve an improvement in our sector, and that we can reduce the greenhouse gas emissions by breeding. And breeding is offering us a cumulative and permanent alternative to reduce the enteric methane from ruminants. We know that there are individual variations in the emission rates, but before we can start to select for reduction, we need to quantify the genetic variance and quantify how heritable this trait is, and we will come back to this later in this presentation. In Geno, we have a climate action plan, and we have concrete commitments for reducing the emissions from agriculture in Norway. Norway has an international commitment to reduce the greenhouse gas emissions with 40% by 2030 due to the Paris Agreement. In addition, the Norwegian government and the agricultural sector have committed to reduce the total greenhouse gas emissions with 5 million CO2 equivalents by 2030. And Geno has already started on different projects and to work with these issues. Geno has a climate ambition to be part of the solution to reduce total emissions from agriculture. We want to select for reduced greenhouse gas emissions in our Norwegian Red dairy cows. In addition, we aim to perform a combined strategy for genetic improvement of the cow's feed efficiency, or how well the cow is utilizing feed resources and their ability to convert feed to milk or beef. We have ongoing projects that will investigate this further, and we will try to quantify the potential to reduce the enteric methane emissions from rumen. Geno is a farmer-owned breeding and AI company. We are responsible for the commercial breeding program of Norwegian Red dairy cattle, which was established in 1935 as a breed. Norwegian Red is also the most common breed in Norway. It is a dual-purpose breed and stands for the majority of the milk production in Norway, in addition to more than 90% of the cows recorded in our national dairy herd recording system is of the Norwegian Red breed. And they have almost 70% of the total carcass production in Norway is also from Norwegian Red. We have a well-established system for recording health and functional traits in Norway. And since 1975, each cow had their own health card where all veterinary treatments are recorded. This has enabled us to perform a selection program with a broad breeding goal, and we have had a major or large focus on functional traits since the 1970s. And this has enabled us to include a large variety of traits. And currently we are selecting on more than 40 traits, which are weighted and included in our breeding program. I will just say a few words about the total merit index of Norwegian Red and the different groups of traits that we have weighted in our breeding goal. Health and fertility is currently weighted with a large relative weight, with approximately 30%. We also weigh traits as calving ease and calf mortality and stillbirth. And we have relatively low stillborn rates in Norway, approximately 3% of the calves are being stillborn. So we are still weighting this trait to ensure that we keep this on an acceptable level and that we achieve genetic progress for calf vitality. Since Norwegian Red is a dual-purpose breed, we have also included beef and carcass traits such as carcass weight, slaughter group, and fat class in the beef index, and this is measured on bulls. And it is currently weighted with approximately 10%, as can be seen marked by red in the figure on the right. So even though all of these traits, these are weighted and they have an economically important value for the farmer, but we think also that many of these traits, they have a positive effect on the climate. And we have therefore achieved indirect effect on the climate due to weighting of these traits. So Geno's contribution for reducing greenhouse gas emissions so far has been due to a genetic progress in health traits. We have reduced the frequency of clinical mastitis in addition to production-related diseases such as milk fever and ketosis. This means that we use less antibiotics and therefore the cows have fewer sick days. A healthy cow will produce more milk and therefore have a higher production efficiency. More productive days through lactation is beneficial when you look at the total emissions within each parity. We have selected for improved fertility, which also leads to more productive days, a shorter interval from calving to conception, and therefore we have reduced the number of empty days, which means we have a more productive cow with more days to dilute the emissions on. Also, improved fertility will increase the number of calves that are born each year. And another important aspect is that the calves are vital and they survive, and calf survival will also have an indirect climate impact. By selecting for improved weight gain or growth rate through the beef index, we have fewer days required for feeding, and the bulls they gain the desired slaughter weight at an earlier stage. Fewer days means less total emissions per animals. For cows, there is an indirect achievement on climate because their emissions can be divided on two products, both milk and beef. And then I will give the word to Kirsti, who will present more about the Genos' future ambition for breeding a climate-friendly cow.
So as you've seen, we've already developed a very sustainable cow. However, we're not stopping at this. As the first sector in our country, the Norwegian agricultural sector has made a concrete commitment to the government regarding reduction of greenhouse gas emissions. Breeding is a very important tool in this context. This is because it gives permanent and cumulative effects. In Geno, we have several ongoing projects that will help us towards breeding for an even more climate-friendly cow. In several regions of the country, we've established what we call high-tech herds. These are both commercial herds and test facilities, and they are geared with high-tech equipment such as advanced automated milking systems with sensors that collect many types of high-precision phenotypes. Direct selection for methane reduction is a whole project of its own, while a new project regarding feed efficiency is also being established these days. The project I'm working on myself is called Selection for Reduced Methane Emission in Norwegian Red Cow. The aim here is to implement routine genetic evaluation of methane emission and publish breeding values for this trait. Through this project, we can update our breeding goal to include direct climate effects. But to do this, we need to examine the trait under Norwegian conditions, as well as to establish the heritability of the trait, as well as correlations to the other traits in the breeding goal. What makes our project quite unique is the amount of data we're collecting. The collection is done using green feed systems. A total of 17 green feeds are installed in both commercial herds and test facilities. They work by expelling feed, making the cow stand near the gas flow sensors, which you can see in the pictures, and the cow visits the green feed several times a day, and we can do continuous measurements on methane and CO2 emissions at individual levels. A big challenge in breeding for reduced methane emissions from cattle is the availability of data. But our project allows us to do continuous large-scale collection from many animals from several herds. This way, we lay the foundations for developing a robust model for estimating breeding values for climate traits. It's important to keep in mind that the enteric fermentation in the rumen of the cow will never be a zero-emission system. Because of this, we need to look at sustainability in a bigger picture. Resource efficiency is important in this context. Breeding towards a more feed-efficient cow is therefore one of our major goals. Methane emissions from cattle is also correlated to feed efficiency. This is because methane constitutes an energy loss. Research has shown that more efficient animals emit less methane. Not the least, feed efficiency is a vital trait because it is the most important economical trait for the farmer. Feed constitutes 50 to 60% of the variable cost at the farm level. The correlations between methane and feed efficiency do, however, need to be examined more closely. Because of this need, Geno has recently established a feed efficiency project with the aim to select more resource-efficient cow. The project is one of the largest in the history of our organization. A system for continuous monitoring of feed intake will be set up. The aim is to phenotype 1,000 cows per year. All of these animals are also in herds with automated milking systems, giving additional valuable data collection. As already mentioned, feed efficiency is a vitally important trait for the farmer. However, it's also about resource efficiency in the bigger picture. Norway is a country with little arable land and large grass and pasture areas. Part of this project is also breeding towards a cow that may improve utilization of Norwegian feed resources. So to sum up, the modern day cattle is much more climate efficient than cattle that has not been bred for increased efficiency in production. Health and fertility combined with increased production has given fewer sick days. Put together with a high milk yield, this makes a more climate-friendly cow that produces more product at lower emission per product unit. But we still have high ambitions towards increasing the sustainability and decreasing the environmental footprint of our cattle. By breeding for reduced greenhouse gas emissions, combined with feed efficiency, we aim to contribute towards a future producing more food with a lower climate impact. Thank you.